All right, guys. So the third problem from the quiz is the type of problem that involves something we call implicit differentiation. So we'll go through that. I've again written down the algorithm for how you should solve these. I'm going to share it with you. For now, I'm not really going to go through it in detail because it sounds a little bit abstract when you're just going through it and reading through it. I think it will be more helpful to just show you how to use it, right? And just go step by step. So what we're given here is 2 plus y squared equals 4 minus x squared. That's what we're starting with. And eventually we need to somehow find y prime of x, which we currently have no idea how to find, right? But let's see how it goes. So the first step would be to transfer all members to the left side of the equation and assign whatever the result is to a new function that we call f of x and y, okay? So again, if I had to give you the full intuition behind this, it would take a while, but because the quiz is so soon, I'm just going to give you the algorithm for solving, right? So what do? As I said, I transfer everything to the left side, and of course, when I'm transferring to the other side, I need to change the signs. So it's going to be 2 plus y squared minus 4 when it transfers to the opposite side plus x2. And as I had written, this whole expression will assign to a function f of x and y. Why is it f of x and y? Because we're used to seeing f of x. Well, in this case, it's just that there's two different variables involved. So that's why f depends on both x and y. And we could just simplify a bit. I typically prefer having the x's before the y's, but that doesn't matter much. X squared plus y squared, and then I have plus 2 minus 4, which is minus 2. So that's my f of x and y. That's first step, okay? So first step is done. Let me actually use green. All right, second step is we are gonna take the derivative of that function that we just had with respect to x. So the correct annotation for this is, so you're not gonna use a prime, you use an x index. That means the derivative of this function with respect to x. So now the question is, what the heck is finding the derivative with respect to x? Like, what the heck is that? So here's how it goes. It's actually slightly confusing at first, but once you get the hang of it, it's actually very, very easy. So here's how it goes. We start calculating the derivative, but because we only care about respect to x, we're going to treat y as a constant, okay? So you treat y as you would treat the number 5 or 0 or whatever it is. It's just a constant, not a variable, okay? So how would this look like? I have x squared. This one I do differentiate because that's what I care for. I care for the x right now. So x squared differentiated is just 2x, right? And then I have plus, but I told you that y will treat it as a constant. So in this case, I just have some constant. No other variable, no x's, no nothing. This is just a constant. What is the derivative of a constant? It's 0. So I'm basically adding 0. And here again, what is the derivative of minus 2? It's going to be 0 again because this is just a constant. Therefore, the derivative of that function with respect to x is just 2x. And that's it. Nothing more. Okay? Now, we're done with step 2. And step 3 is doing literally the same thing, but this time with respect to y, because we don't discriminate, right? So we need to do the same thing with respect to y. So fy of x and y equals. So once again, I need to take this function and differentiate. But this time, because I only care about differentiating with respect to y, I'm going to consider x to be just a constant. So if I have a constant squared, this is just a constant. And the derivative of the constant is 0, right? So that's going to be just this part here. So the derivative of y squared is 2y. That thing here is still a constant. It doesn't change. So the derivative is going to be 0. Therefore, this is my final answer for fy of x and y. Okay, these are my two derivatives with respect to x and y. Okay. Step number 4. So we take these that we just found And in order to find y prime of x, which is what the question asks about, right? It asks about y prime of x. So y prime of x, and there's a formula for this, and it's a very easy to remember formula. The only tricky part is you need to put a minus in front, just don't forget about this. And then you have this thing over that thing. So it's gonna be fx of x and y divided by fy of x and y. So in this case, it's going to be minus 2x over 2y. I can cancel out the 2's, so it's just minus x over y. So that's our formula for y prime of x. But, we're not ready with the entire problem yet. We are already up to here. This part we figured out. But now I need to figure out y prime of 1, okay? So obviously, I'm plugging in 1 for x. But the problem is the formula has both x and y. So how do I find y in this case, right? So x will be 1 because I just plugged in 1 for x in the formula. But how do we find y, right? By the way, don't write this down on the exam this way. I'm just explaining my thoughts in written form. How do we find it? So there is an explanation here at the bottom. I just wanted to show it to you. So if only the x or y coordinate is given, first plug it into the original equation to get the other coordinate and then go back to step 5. So in this particular problem, we're given x equals 5, but we don't know what the y will be for this formula. Or you could use this one. Yeah, this one would actually work better, right? So I know x is 1, so I can just rewrite the thing, but plug in 1 for x. So x is 1, so that's going to be 1 squared. Therefore, I have 2 plus y squared equals 4 minus 1. 2 plus y squared equals 3. Y squared equals, that goes to the other side with the opposite sign. So 3 minus 3, which is 1. And y equals plus minus 1. Okay? Okay, perfect. So from here, for that final answer, it follows that there's going to be actually 2 answers because we have 2 possible values for y. It could either be plus 1 or minus 1. Therefore, the way we write it down is f prime of 1 could either be minus 1 over 1 if we consider y to be 1, which is minus 1, or y prime of 1 could be minus 1 over, and now if y itself is minus 1, we just have another minus 1. Minus and minus gives us a plus, so the answer is 1. So these are your 2 answers to this particular problem. Okay, let's now take a look at the other one. I don't know where it went though. So that's the first one that we did. Whoa, where the heck did the other one go? Okay, this is the other one. I think this one is easier, actually, not sure. I think the derivative is harder, but it's easier from the perspective that we're given, let me show you, both coordinates of the points. So we don't need to go back and calculate y in the original formula. We just have both coordinates. Okay, anyway, let's do this one. Okay, so we have x squared y squared plus xy equals 2. And now let's just go through the steps once again. First step was move everything to the left side and assign it to a function called f of x and y, right? So move everything to the left and assign it to a function. So my f of x and y would be x squared y squared plus xy minus 2 because I need to bring this to the other side, and then of course I change sign. Okay, perfect. How do we proceed from here? We have that f of x and y, and now the next step is to take the derivatives with respect to x and then to y, right? So firstly, with respect to x, fx of x and y. So how do we calculate this? Once again, because we care about the x, we're going to treat the y as a constant. Now, this time, it's not just the constant, so the derivative is not going to be 0, But imagine this was something like, I don't know, 4, for example, just testing. This is not true. We're just imagining things in order for you to understand it more easily. So if this were 4, then for the derivative, we would just keep the 4 as it is, and then we would calculate the derivative of that thing and multiply, right? So in this case, of course, we don't have 4, but because we're treating the y squared as a constant, I'm literally just gonna copy it. The same way I would copy the 4 with no change whatsoever. And then for the derivative of that thing, it's just 2x, right? So of course, this could be rewritten as 2xy squared, which is slightly better. Then we need to take the derivative of xy. As I told you, y literally just a constant, so I keep it this way. If it was only y, by the way, without the x, then the derivative would actually be 0. But now I have multiplication, so I just keep the y this way. And then what's the derivative of x? It's actually just 1, okay? Derivative of x is 1. And then this, because it's purely a constant with no x or anything associated with it, its derivative is going to be 0. Okay, and now I need to calculate similar thing for y. So this time I only care about y, and I treat x as a constant. So this is a constant, I just copy it. Derivative of y squared, derivative of y squared is 2y. Or if I were to rewrite it, it would be 2x squared y. I'm just switching places of the variables. Okay, then I have, so in the original, it was actually xy, right? So I write a plus. And then again, x I keep as a constant, so I don't change it. Y, what's the derivative of y? The derivative of y is just 1, okay? And then I have minus 2, which derivative is 0. By the way, as you can probably notice, these are actually very symmetrical, very close to each other. Most of the time when you're doing implicit differentiation, it looks like that. Okay, from here, we need to find f prime of y, what was it? F prime of x. Even I forget the formula sometimes. Is that true? F prime... Oh, sorry, y prime of x. Oh my god. I don't even know where that small f came from. Forgive me, I'm really tired. But I just had to do this urgently because the test was changed. So anyway, y prime of x. What does it equal? It equals minus fx of x and y over fy of x and y. And then I just plug in the values. So fx of x and y is this thing. So I just plug it in. I don't forget the minus in front though. And in the denominator, I just place this thing, which is 2x squared y plus x. Can we simplify? Not really. We could just we actually cannot cancel out these 2's. Just be careful here. We could have canceled them out if we had it like this in front of parentheses. But in this case, we cannot cancel out. We could just pull out one y in front here and one x in front in the denominator, but it doesn't help us at all. So I'm just going to leave it this way. All right, now I'm given a specific point in this case. So I need to calculate y prime of 1, which means that x is going to be 1. And then they've directly given me the instructions that y is also going to be 1. So y prime of 1 equals 2. And now for x, I replace 1. And for y, I also substitute 1. Okay? This is the point that they've given me. If the point was, for example, 1, 2, then for y, I would substitute 2. But in this case, both are 1. So it's super easy to calculate. Actually, it's going to be minus in front. And then I have 2 times 1 times 1. Oops. Plus 1. Over 2 times 1 times 1 plus 1. So that's minus 3 over 3, which gives me minus 1. And that's my final answer, right? Because they asked me to find y prime of 1, and I just found the value.